And in this video, we're going to take a look at permutations, permutations of like objects, combinations, and then using permutations and combinations in probability problems. So a permutation is an arrangement of things that have to go in some specific order. So think about it like a combination lock. You have to enter those values in order. A password, you have to enter things in order, but there are no repetitions allowed. The fundamental counting principle is related to the concept of a permutation. It says that if something can occur in ways and then another event can occur in ways, then I can actually multiply m and n to get the total possible ways something could occur. So for instance, if I'm flipping a coin and rolling a die, and I want to look at what is the number of ways I could flip a heads and then roll a 3. So it would be 1, I could have 1 here and flipping the heads. I have 1 way to roll a 3, so there's 1 times 1. That's the number of outcomes that would occur for that particular situation. If I wanted to look at maybe outfits, let's say I have 5 shirts, 4 pairs of jeans. If I want to know how many outfits I can make with 5 shirts and 4 pairs of jeans, I know that an outfit would be my shirt and my jeans. So I have 5 times 4, which is 20. So that saves you basically the process of creating that probability tree. A factorial is when we use an exclamation point to basically break down and factor a number. So 5 factorial would be 5 times 4 times 3 times 2 times 1. So that a permutation is utilized with this formula. I'm going to post some Web 2.0 videos. There's actually a button for the permutations that's used, so be looking for that in the announcements as well, because we will utilize that button and not this formula. So a baseball team has 9 players. If I want to find the number of ways the manager can arrange the batting order, so that means the first batter has 9 options. The second batter, though, only has 8 options because he can't bat again. Then there's 7, 6, and so on. So I'm going to do those slots. So there are 9 for the first batter, 8 for the second, 7. Multiply them all together. So there are 362,880 possible ways to run that batting list. If I want to look at finding the number of ways of choosing 3 initials from the alphabet, if none of the letters can be repeated, that's a permutation. How do I know it's a permutation? First of all, I'm choosing a certain number of items from a group. So I'm choosing 3 initials from a group of the alphabet. It's also a permutation because none of the letters can be repeated. If something can't have repeated things, that's going to be a permutation. So in Web 2.0, you would click 26, NPR 3, and you would skip this whole formula process, and it would give you 15,600. Permutations with objects that are alike are going to be a little bit different in an arrangement of n objects. If I have like objects that are indistinguishable, then I would be able to utilize this different formula here. So I'm basically losing the n minus 1. So what are like objects? Find the number of arrangements of the letters of each of the following words. So I have 3 B's in common here, and I can't have doubles, right? Permutation means the order of things. I can't have repeats. So I take the total number of letters and I divide by the number of times something repeats. So B repeats 3 times, so I divide by 3 factorial. This has to be done without the NPR button. If I look at statistics, I have 10 total letters, I have 3 S's, 3 T's, and I have 2 I's. So I have to divide by 3 factorial, and 2 factorial, so I don't get that repeated arrangement. So I get 50,400. Now a combination would be when the order makes no sense. So it's not a password. A password, the order of letters we enter into the computer has to be correct. So that's not a combination. A combination lock is not a combination because a combination lock, you have to put the numbers in a specific order. So to find the number of combinations possible, we are going to use NCR. So look at the Web 2.0 video. You're going to you type the number in for N, you push NCR, you type the number in for R, and you hit enter. It bypasses all of this formula. So the Library of Science Book Club offers 3 free books from a list of 42. How many possible combinations are there? Well, the order that you select books in doesn't matter. There's no password or check process that's going to make it matter if what book comes first. You're choosing 3 from 42, so it has to be a combination because you're choosing from a group. So I'm going to do 42 times 41 times 40, or I can also arrange that utilizing the combination formula. So either way, you're going to get to the same possibility. You're going to get 11,480. So you would hit the 42, that's your N. You're going to hit NCR. You're picking 3, that's your R. So you have 42, NCR, 3. It bypasses that whole formula for you and gets you to the final answer. At the beginning of the first semester of a math class for elementary school teachers, each of the class's 25 students shook hands. This is a very, very common application of this for standardized testing. With each of the other students exactly once. How many handshakes took place? Well, it doesn't matter the order in which handshakes happen, so it's going to be a combination. A handshake may not seem like it's picking from a group, but you are, right? Two people shake hands, so you're picking groups of 2 from 25. So your N is 25, your 2 is R. So I'm going to hit 25, NCR button, 2, and hit equals. And there are 300 handshakes that took place from just 25 people. Here's another example. Given a class of 12 girls and 10 boys, how many ways can a committee consisting of 3 girls and 2 boys be chosen? So because it doesn't matter, no one place on a committee is higher than another one, it's going to be a combination. I have 12 total people. I need to pick 3 girls from that group of 12. So then the boys would be from 10 boys. I'm going to pick 2. Now, because these events are happening, it's multiplying like probability. So you're going to multiply the NCR and the NCR to get 9,900. Then, if I want to say, well, what is the probability that a committee of 5 is chosen at random from the class that consists of 3 girls and 2 boys? Again, it's a combination. I'm picking 5 people. So I've got that. From part A, we know that there are 9,900 ways to choose 3 girls and 2 boys. So if I'm looking for the actual probability, I'm going to take that 99,000, divide it by the total number of possible outcomes, which would be just picking 5 from 22, not caring if they're girls or boys, and I would divide them to get 38%. So the key here is when you see what is the probability, that means you're going to have to take it a step further than just doing the combination of the permutation. Now, if I'm looking at the probability that a committee of 5 chosen at random from the class has no boys, that's going to remove a group of people from that class total. So I have to basically pick 5 girls out of the 12 girls. So when I'm picking 5 girls out of 12 girls and no boys out of 10 boys, I'm going to multiply those two together. And it's not going to be 0. It's going to be 792. The last one would be, what is the probability that a committee of 5 is chosen at random and consists of only girls? So this was have no boys, consists of only girls. So that means I'm going to be picking 5 from 22, and that's my total number. I'm looking for probability, so I know I'm doing some division. So then I want to say, well, how many ways are there to pick the girls, the 5 girls, which is 792? I divide them and I get 3%. So when it says, what is the probability in a lab? You're not looking for how many, you're looking to divide how many by how many total. So picking 5 out of 22 can be done 26,334 ways, but from earlier, I can only get 5 girls 792 ways. So I'm dividing those two values.